All right, so what I want you guys to do to start off is take your unit circle that you filled in, and you're going to fill in some angles. So you're going to start at 0. So 0 is right here. All right, and so you would put 0, the 0 angle there. All right, and then you're just going to fill in, going around the circle, the next angle. So the next angle would be pi over 6, which would be this one right here, and then pi over 4, and then 3 pi over 3, and then pi over 2. So go all the way around the unit circle. And pause the video if you need to do that. All right, so eventually, this is what your unit circle should look like. And we're not going to get too dependent on this unit circle because you are going to be able to use it when we're doing a test or a quiz. But we're going to use this unit circle to get the graph of sine of x and to get the graph of cosine of x. And so if we're using the unit circle, if you guys remember, the radius is 1. So r is 1 at all these points. They're 1 unit away from 0. And so if we want to find the sine of an angle, we're just going to use the y coordinate. And then if we want to find the cosine of an angle, we're just going to use the x coordinates. All right, so when I come down here, I'm going to do the graph of y equals sine of x. I'm just going to start with 0. We'll talk about the negatives in just a second. So the sine of 0 is going to be the y coordinate when the angle is 0. So that's going to be 0. So we have a point at 0, 0. Right? The next angle we have is the angle pi over 6. So if you look at your unit circle, when the angle is pi over 6, look and see what the y coordinate is. So when the angle is pi over 6, the y coordinate is 1/2. So what that means is we have a point at pi over 6, 1/2. Right? And we'll go to pi over 4. So you look at your angle pi over 4. The y coordinate is the square root of 2 over 2. Right? Then when you go to pi over 3, the y coordinate should be the square root of 3 over 2. Yep. It's kind of hard to see some of these lines. Right? And then for pi over 2, it should be 1. Right? And then you guys just keep going around your unit circle, plotting points. And pause the video. I'm fairly sure I can do it faster than you guys. Not that it's a race. It's really hard to see the line right there. Okay. So pause if you need to. All right, let's talk about these negative angles. So negative, we have the negative pi over 4. So that would be rotating the pi over 4 distance, which is this much right here, but rotating in a negative direction. And so the sine of negative pi over 4 is going to be negative square root of 2 over 2. All right, and then same thing here. If we want negative pi over 2, we would rotate this amount, but we would rotate it in the negative direction. So that's going to be negative 1. All right. And then we would connect this in a curvy rounded, smooth graph. It's not easy to do on this iPad. And it's going to keep going in that direction. It's going to keep going in the other direction as well. That is part of the graph of the sine curve. Let me see if I can make it a little bit better. Still not good. All right, so one period of a sine curve, like sine, all the trig functions curves are periodic, which means they repeat a pattern over and over and over again. So this shape right here is considered to be one period of a sine curve. And so this particular sine curve completes the period in a distance of 2 pi. That's the length of the period. All right, and then the amplitude is the height of the graph from the middle, the midline, to the highest point, that distance. All right, and so the midline is here, the highest point is here. That's a distance of 1, so that would be the amplitude. You could also go from the distance from the middle to the lowest point. That's also going to be 1. Okay, so let's erase this. Don't really need to write that. I just want you to see a good curve of the sine graph. Okay, let's do the same thing with cosine. However, when we are finding the cosine using the unit circle, we're going to only use the x coordinate. So as we go around, we need to find the cosine of 0. We use the x coordinate, so that's 1. The cosine of pi over 6 is the x coordinate, so that's the square root of 3 over 2. So I want you guys on your own to fill in that cosine curve. So I really don't want you to just watch me do it. I want you to do it on your own. So pause if you need to. Okay, so if you're not done, pause it and then start it. So this shape right here is one period of a cosine curve. So I always tell my students that one period of a cosine, I don't know why, to me it reminds me of a Texas Longhorn. So the period of this particular cosine curve is 2 pi. And then the amplitude is the same thing as before. So it is the distance from the midline to the highest point, which in this case is going to be 1. Now the period and the amplitude do change from problem to problem. So tomorrow we'll start doing some more complicated graphs where the period and the amplitude changes. So the graphs look a little different, the same basic shape, they just look a little different. All right, and then we're going to fill in some stuff on this key characteristics sheet. So again, the amplitude is the maximum distance it reaches from the baseline. The period is the time it takes to complete one cycle. Now, phase shift we haven't talked about yet, but we will. It'll be a shift left and right, and then vertical shift will be a shift up and down. So what changes the amplitude from problem to problem is this number in front. So on ours, where we just did the cosine of x and the sine of x, the number in front was 1. So our amplitude was 1. So the amplitude is going to be the absolute value of whatever number that is. Okay, and then what affects the period is this number in front of x. So if your x has a coefficient, that's going to affect the period. And so the period is going to be 2 pi divided by the absolute value of whatever that number is. So the amplitude and the period are never going to be negative, so that's why we use the absolute value. All right, we'll pick up with some more graphs tomorrow.